Okay, so again, as I said, we're going to talk about the chain rule, and we need to focus on what this rule is. And this is our last derivative for this unit. We will learn plenty more. So our chain rule here is when you have a composite function, meaning one function inside another, for example, f of g of x, you take the derivative of the outside with the inside still in there, meaning when I bite into that M&M, the chocolate's still on the inside, right? I get the candy shell first. Then I have to take the derivative of the inner layer, which in that case would be the chocolate. Okay, so this is the derivative right here. I really hesitate to give you the error because it's like when someone says to you, don't do that, what do? We do that. Don't touch that, it's hot. Oh, what, this? Okay, so this is a common mistake. It's bad. Okay, I saw this actually on some of the quizzes. I know I said you couldn't use a product in the quotient rule, but there's other ways to do things. And some of you took the derivative of f and the derivative of g, and that was a big fat no-no. If you went back one, it was a sad face. Okay? So we have to really be careful and think about what we're doing. All right, so here we have our first function, and it is a composite. And I'll give you this example. This is what we would consider a plain M&M. So here we have the outer shell, which is to the 60th power. Our chocolate is comprised of this polynomial on the inside. Okay, so this is just a simple two-layer. We're going to take the derivative of the outside first, meaning I'm thinking about this as maybe x to the 60th power. Okay, this is how I'm thinking about it. So what's the derivative of x to the 60th? 60x to the 59th. Okay, so that means when I take the derivative, y prime, it will be 60. Then I've got the 2x squared minus 4x plus 1 to the 59th power. So I bit into that outer candy shell. Now I'm getting to the chocolate. I need to deal with the middle. What's the derivative of 2x squared minus 4x plus 1? 4x minus 4. You're done. That is the derivative. You literally, I guess you could take 60 times this binomial here. But I'm not going to make you multiply this thing out 59 times. There's not enough paper in this room for you to do that right now. Okay? Okay. Questions on this? By the way, if you want a snack, you may. Yes?
So, is the...
Trash goes in the trash can, please.
Is that one answer?
That's your answer. It's multiplied together.
Okay.
It's the product. So see here, this is f prime g of x times g prime that you're multiplying. So then if you had 3 layers, it would be shell, chocolate, peanut.
Okay.
Does that make sense?
Yeah.
Okay. All right. So in B, since we are not going to use the quotient rule on this, how do I rewrite this in friendly form? What do I do? Make it friendly. Yeah, bring everything to the top. So this is going to be the quantity of 2x to the 5th power minus 7 to the negative 3rd power. Okay, so when you look at this, you need to think to yourself, how many layers do I have here? Plain or peanut? Plain. I got an outer shell and a chocolate. Okay, so we're going to take the derivative of the outside first. So we have y prime is equal to negative 3. Then I've got my polynomial on the inside. And this is to what power? Negative 4th. And then I need to take the derivative of the inside. So what's the derivative of the inside? 10x to the 4th power. Okay, so technically you are finished. You do have your derivative, but this can be rewritten. We could rewrite this as negative 30x to the 4th over 2x to the 5th power minus 7, and that 4th is on the bottom. Okay? You do need to simplify the negative exponent. These you don't have to multiply, but negative exponent should be simplified, yeah. Okay. What about C? I need to rewrite friendly form. 2 things need to be rewritten. It'll help me just a little bit. Okay, so bring this quantity to the 1/2 power. What about 1 over x? How can I rewrite that? That's right. So what we have here is the quantity of 1 plus x to the negative 1st to the 1/2 power. Plain or peanut? Plain for sure. So this is 1/2. Then we've got 1 plus I'm going to leave it as x to the negative first for now to the negative 1/2. Is that right? And then I need to take the derivative of the inside. What's the derivative of 1? And then, careful, x to the negative first. Yeah, negative x to the negative second. Okay, there's a whole lot of simplifying that needs to go on here. And I will tell you, when you simplify it, it's going to look probably just as messy as it does like this. Okay, but there's a lot of negative exponents here. So what we have is, I'm just going to write this fraction, okay? Because there's a lot of stuff that's staying in the top versus what's going in the bottom. Does this go on the top or the bottom? Bottom. This is going to stay on the bottom. Okay, this negative, can I write a negative 1 in the top? This negative? Yeah. I mean, it doesn't matter. It could be in the top or the bottom. It's still negative. Then we've got 2x squared. That's this part. This whole thing goes on the bottom because it's the square root, and then this is a fraction inside, right? So you could write it like this. Or you could write this as a radical. But at that point, I mean, it's already a hot mess, so I would just leave it be. Okay, simplify negative exponents, please. Okay, I'm actually going to skip D and I'm going to go to E, but D is similar. It's a trig function, but I want to show you, whenever you have trig functions, just like in the calculator, when you type the tangent, you can't put that square there, can you? No, you got to put it on the other side. So the deal here is, excuse me, when you have a trig function, you should rewrite this first, because then it, excuse me, shows you your layers a lot more clearly. So this cube, I'm actually going to put it on the outside. So I'm going to rewrite this. We're all on E. So this is the cosine of x squared, and this whole thing is cubed. All right, now I've asked you this before. Is this plain or peanut? Yeah, this is peanut. I got 3 layers, right? What's my first layer? The cube, right? What's my chocolate layer? So then x squared is my peanut. Does that make sense to everybody? Okay, you can just kind of think about what the layers are. Okay. So we're going to do this, just as we said, go through every single layer. So we've got y prime is equal to 3 cosine of x squared squared. That's the first part, right? Second part, we're dealing with the cosine. What is the derivative of the cosine? Negative sine. So we've got negative sine of x squared. And then the last part, 2x. Okay, at this point, is my derivative complete, yes or no? I took the derivative, I'm totally done. However, there are some things you can combine. For example, the 2x and the 3 and maybe this negative 1. So then I could rewrite this as negative 6x. And then you've got cosine of x squared squared sine of x squared. Either one is acceptable. So, FYI, which one of these two, first or second, do you think you would see on a multiple choice? Definitely the second. Okay, so you do need to practice simplifying so that you can recognize, oh wait, this is not. Now, free response, are you good to go here? Can you stop? Absolutely. Absolutely. Okay, so question so far, how are we doing? Everybody okay? Honesty, yes? Yes, sir.
Wait, did that negative 6x like come from the negative side?
So 2x times 3 is 6x, and then this has a coefficient of negative 1. I just combined all the coefficients. So I couldn't take anything like in here. I'm just making this up, but let's say this 3 was inside. I couldn't take it because this is squared. Do you see what I'm saying? Do you have the numbers that we can't use? Oh, sweet. Thank you. Awesome. Thanks. Okay. All right. With this last question right here, this is actually a really good question because not only do we have to use the product rule, but we have to use, inside the product, we have to use chain rule. So we have 2 terms. We have the sine of 2x, and we have the cosine of 3x. So these two are being multiplied together. So, did I answer your question? I did. Okay, I just wanted to be sure. I was distracted. Okay, so we're going to create this table here. Okay, and we've got f is equal to the sine of 2x, and g is equal to the cosine of 3x. Okay, so you could think about this even though there aren't parentheses. Essentially, you do have parentheses here. They're imaginary, but if it helps you delineate, put them in. Because now, what do I have here? Plain or peanut? Plain, for sure, right? We have an outer layer, which is the trig function, and the inner layer, which is the coefficient in the variable. So for f prime, my derivative would be cosine 2x times 2, right? Outer layer, what's the derivative of sine? Cosine. Derivative of 2x is 2. But doesn't it look better if I write it like this? 2 cosine 2x. Aesthetically, it just looks nicer. Okay, so think carefully. First of all, what's a derivative of a cosine? It's negative, so I'm going to have a negative coefficient, and then what's the coefficient going to be? Negative 3. So g prime is equal to negative 3 sine of 3x. Jay, you good?
I'm having difficulty understanding the first, like the outer layer derivative, like what here.
Okay, so the outside is just this whole thing. So the derivative of the cosine is negative sine of 3x. You leave that 3x alone. Okay, then I do the inner. So you got to that gooey candy on the inside of the Skittle. So now you take the derivative of 3x, and it's just 3. But this will just look so much more visually pleasing, aesthetically nice. It's what we're used to. We have the coefficients always in front. Okay?
So we haven't done the inner yet. We're going to do that after. Like you do the...
We did the outer first.
Yeah.
Oh, I haven't even done the product rule yet. I haven't gotten there. I'm getting to it. I know, it's a process. Okay, so this was the setup for the product, but inside that product rule we had to use the chain rule.
Yeah.
That was the whole thing. So now y prime is equal to, this is figgy, it's f prime times g. So f prime times g is just 2 cosine 2x cosine 3x. It's f prime g. And I'm not going to put a minus or a plus. We know it's supposed to be plus something, but because my fg prime, that product is negative, right? I'm going to put this negative 3 here, and then it's either sine of 2x or sine, it's up to you what you want to put first. So this would be sine of 3x, sine of 2x. Could these two be flip-flopped? Meaning sine of 2x first and sine of 3x second? Yes, commutative property and multiplication. So it doesn't matter, as long as they're both there. I cannot simplify this anymore. We're done. That's it. Okay, but you got to take each step pretty carefully. And it does take practice. Okay? Questions? You sure? Okay.